Hello, in this video we're going to be talking about the general information for nervous tissue, so let's not waste any of your time. Let's get right to it. Now when we're talking nervous tissue, in this unit, one of the first things we want to talk about is that it's a combined effort to maintain all the situations that you've got going on in your body: temperature, pH levels, oxygen levels, everything. And those two systems that work together are obviously the nervous system and the endocrine system. And the endocrine system we'll talk about in a later video, but a super important system, and you'll see then that it's such a small part of the overall structure of the body, but man, super important. But those two things work together. The endocrine system receives information from the nervous system, from the brain and hypothalamus, and then from whatever the chore is, goes out from there. But the nervous system sends out the signal, and the endocrine system sends out the chemical messengers, hormones, or whatever is needed. Alright, so the nervous system, as I'm sure you're aware of, it's got three basic steps. Somewhere within your body you get a stimulus, some kind of a change, some kind of a recognition of something, whether it's on your skin, in one of your receptors, or maybe an organ, a muscle sends out a message, and of course then that goes to the spinal cord and up to the brain for part two, and then the decision is made what to do, and it sends it back out. And the rest of this video lecture will be spent on that process of these three: the original signal, where it comes from and how it gets to the spinal cord and up to the brain, and then back out to wherever it's going to go. Alright, so when we're thinking about the nervous system and nervous tissue, the first thing we want to recognize is that there are two functional divisions. You've got your central nervous system, which from here on out will be known as the CNS. Both during this lecture and I'm sure in class you'll hear that, but certainly on a test question, quiz question, just to save space and time, CNS is what you will see. But that is the components of that is the brain and the spinal cord. That's your central nervous system. The other division is the peripheral nervous system, which for here on out will be known as the PNS, in all the places I just listed for the CNS. But the peripheral nervous system, that is all the other components of the nervous system. That's the receptors, the line of nerves extending out from the spinal cord out to the muscles, to the organs, and then the ones from the organs and muscle and skin to the spinal cord. One of the things that you'll see once we get to I can't remember if it's in the spinal cord chapter or the brain chapter, but it's a beautiful, not beautiful is not the right word, but a great diagram which shows you the nerve path and the pathway out from the spinal cord. Not all messages go to the end of the spinal cord and work their way up. It's basically done in layers. So something on the upper part of your body just goes straight into the spinal cord and then up and then out again as needed. So like your legs, things from your legs and your hips, they might go to the end of the spinal cord and then up, but it's done in layers. But you'll see that in time. Now, within the PNS, peripheral nervous system, the way to get to the spinal cord and the way back from the spinal cord are two separate sets of neurons. So it isn't like it's just one road in and one road out. It's basically like two roads side by side, and one road is the going in, so they're both one-way streets, and then the road coming back from the spinal cord is a different road. And the two words you want to be aware of is afferent, which you can see on the screen, and efferent. Afferent means it goes away from the skin or the receptor to the central nervous system. Efferent, with an E, means it's coming from the spinal cord to the receptor, wherever it may be, in the nerve, muscle, skin receptor, wherever. So those are the two words that you just got to get, you just got to work out. Afferent, away from the skin, away from the receptor, and efferent, returns from the spinal cord in the brain. But your sensory division, your afferent division, as you can see, that's where the signal is received, some kind of a sense receptor, and it goes to the spinal cord. Now, if it's and so we're talking, wherever around the body, and so, but if it comes from and of that, so the sensory division, that's just your general term for any receptor, wherever it may be. Now, if it comes from skin, muscle, bones, and joints, you can see it's called the somatic sensory division. Okay, so the word that isn't listed there is organs and glands. If it comes from organs and glands, okay, then it's the visceral sensory division, or it used to be called the atomic, as you can see there. So if it comes from skin, muscle, bones, and joints, then it's the somatic. Okay, body, and you've seen that word in cell division. Somatic means body cell. If it comes from an organ or a gland, okay, then it's the visceral sensory division. And the sensory means it's going to the spinal cord. Now, if you see the word motor division, that means it's returning from the spinal cord. It's gone up to the brain, the decision's been made of what's happened, and now it's returning, and that's efferent, as you can see there. So if you see efferent division, I mean it's returning from the brain, whatever decision's been made. Or if you see the word motor division, and again, motor division is your umbrella term, and then again, is it somatic or is it visceral? If it's somatic, again, it's going out to the muscles, skin, wherever, and of course, wherever it's going, those are called the effectors, the cells, organs, glands, wherever the message has to be sent to. But if it's somatic, okay, so we're talking skeletal muscles, and so if we're talking visceral, okay, again, autonomic, glands, cardiac muscles, and smooth muscles. So when you're thinking motor division, okay, somatic, it refers to only skeletal muscles, only to skeletal muscles. Anything else is visceral. Okay, so if we have a question that says which one of these does visceral motor division not go to, you're looking for skeletal muscles, and you may be thinking, well, aren't all muscles skeletal muscles? No, because your heart would be considered a muscle. Your intestines could be considered a muscle. So there is a difference. Okay. Now, and And then two other things to think about, as you can see there, sympathetic and parasympathetic. Sympathetic are things that if they need to be increased, okay, sympathetic division, or if it's parasympathetic, needs to be slowed down. And so maybe it's a fight or flight situation and your heart rate needs to increase. Okay, so that would be sympathetic. And then once the situation has resolved, now it would be follow a parasympathetic pathway to slow down the heart rate. So those are, just keep those terms in mind: sympathetic increase, parasympathetic decrease. Now here's a great little chart that you would obviously want to write down and keep track of. But you've got your two subdivisions there at the top: central nervous system, peripheral nervous system. Central nervous system is the brain and spinal cord, and then the peripheral nervous system is everything else: the ganglions, the nerve tissue, all the receptors, everything else. And you've got your sensory division, which is the division that sends the signals to the brain, and your motor division, which is returning from the brain. And in your sensory division, you got your visceral, which was the organs and glands, and then your somatic, which was everything else: muscle, skin, everything else is part of that. In your peripheral nervous system motor division, okay, that's returning from. Remember, somatic was skeletal muscle only, and then visceral was everything else. Okay, and of course your two sympathetic, I'm going to increase something. Parasympathetic, I'm going to decrease something. Alright, now we're thinking neurons in general. Okay, there are three things that neurons do, universal properties you can see there. One, that they're excitable. Okay, and that doesn't mean like excitable like you and I get when, you know, we're excited about something. It just means they're being stimulated by a nervous, by a signal from a previous neuron. They're excitable conductivity. In other words, they're going to, and when we do electric potential, you'll see this, but they conduct electricity, and it inspires them to, or it activates them to fire to the next one. And we'll talk about that in electric potential, which is will be our longest video. It's got a lot of stuff in there. And then of course 3, secretion. To get that message to the next neuron, neurotransmitters are used. So we're going to secrete neurotransmitters and some other elements as well. Calcium, potassium, and sodium all play a part in getting that signal to the next neuron. Alright, so when it comes to neurons, there's essentially 3 types. One, obviously, there's sensory, okay, the afferent. These neurons are the ones that detect the stimulus, and then they send that message to the brain and spinal cord. Then the other one, the opposite of that, motor neurons, are from the brain and spinal cord out to wherever the effector is, whether it's got to go to a gland, muscle, skin receptor, whatever. Those are the 2 types. And just remember, efferent means it's returning from the brain. Afferent means it's going to the brain. Okay, and the third type, which is the one that's in the spinal cord and brain, that's the interneurons. And as you can see there on the screen, that's most of the neurons of that, 90%. But these are the neurons that receive the signal, and these are the neurons that send out the response the interneurons. And here's a nice little graphic showcasing those three. The first one, the sensory, and then it goes into the interneurons, and then once the decision's been made what to do, back out to the motor neurons, and then wherever the signal needs to go to a muscle, gland, organ, receptor, wherever it may be, the efferent system. Well, that's our video over the nervous tissue general information. When we come back together next time, we're going to be talking about neurons. So we'll see you then.